Hello everybody and welcome back to another Project 45 video for HL/SL Chemistry. Today we will be covering a topic in Reactivity 2.1, which is the molar ratio. So the success criteria for this topic is as follows. You should be able to calculate reacting masses and or volumes and concentrations of reactants and products. There are two main formulas you need for this topic. The first one states that moles is equal to mass over the mr being the relative formula mass of your compound. And the second formula would be moles is equal to concentration times volume. Here we have a question asking about what mass of aluminum oxide is produced when 135 grams of aluminum is burned in oxygen. Here we can see the chemical equation, which is 2Al plus 3O2 arrows to give AO2O3. So the first thing we can take from this question is the key terms. So here we can see that mass is highlighted in red, which means that we are immediately going to use this formula saying that moles is equal to mass, which is the important part, over mr. The next part is trying to find data from the question and trying to link it to this equation. So here we have 135 grams of aluminum, and that applies to this aluminum molecule here. So we can actually plug in the values into this formula. So you see I put the 135 grams into the top part of the equation, and from my data booklet we can find the mr of aluminum, which is 26.98, and when you calculate that out using a calculator you would get a value and round it to 5. So what I've done here is basically I have rearranged the formula to give mass, because it's asking us what mass of aluminum oxide is produced. And also here I've just used this notation to say the moles of aluminum is 5. Now an important thing to consider when doing these types of questions is the coefficient of these molecules, these products, reactants. So you can see there's a 2 here from the Al, but there's no coefficient of the aluminum oxide. And what this is saying is basically for every 2 parts of aluminum that you put in, you only get 1 molecule of 1 part aluminum oxide out, which means that there are double the amount of moles of aluminum than there are aluminum oxide. This means that we can put the moles of aluminum oxide to be 5 over 2, which is 2.5. Plugging this into the formula, we get M equals to 101.96, which is just using your data booklet to find the mr of Al2O3. And you multiply that by 2.5, and this will give you an answer of 255.1 grams. Here we have another example question, and this one says that 0.025 decimeters cubed of 0.1 mole per dm cubed NaHCO3 solution were titrated with dilute H2SO4. 0.0152 decimeters cubed of the acid were used to neutralize the solution. Calculate the concentration of the acid. And at the bottom here we see our chemical equation again. 2NaHCO3 plus H2SO4 gives Na2SO4 plus 2H2O plus 2CO2. Similar to the previous question, we can find some keywords in the question, and here it's concentration, immediately telling us that we can use this formula. Now let's quickly calculate the moles of NaHCO3 by finding the data in the question, which is 0.025 and 0.1 being the volume and the concentration, and that will give us 0.0025 moles. Similar to the previous question again, we can see that for every 2 parts or 2 NaHCO3 molecules, only 1 H2SO4 is needed to neutralize them. Therefore the number of moles is double, and we just need to divide by 2 again to find the number of moles of H2SO4. And the last step to calculate the concentration of H2SO4, all we have to do is just use the formula and rearrange it slightly to get 0.00125 divided by 0.0152 from the question to get 0.0822 moles per dm cubed to 3 sig figs. Thank you for watching another video. Please check out our other content on Instagram and YouTube, and like and subscribe.